Welcome to Unchatted Waters. In this episode, we talk about marine litter. So if you're at your bathroom sink daydreaming about your day ahead, this episode talks about where that toothbrush might end up when you've finished using it. We talk about marine litter monitoring and how changing our behaviour and attitude can bring about positive change, making sure humans only leave footprints for future generations. Welcome to Unchatted Waters, the podcast that talks to the people behind the science. I'm Kirsty, your host, and I'm excited to introduce my two guests for this episode. Briony Silburn is a marine litter scientist, researching seafloor litter in the UK and monitoring marine litter across the globe, including in the South Pacific and Middle East. Holly Nell is a marine scientist working on marine litter from detection to how plastics move through the marine environment. She considers litter across all size ranges and has worked across Africa. So welcome to the podcast, both.
Hello. Thank you for having us.
Brilliant for you to be here. So I want to start off with a simple question, Briony. What is marine litter?
Okay, so marine litter, I hope that most people would have a good idea themselves of what it should be, but we define it globally as any persistent or manufactured, so man-made, processed, solid material that's been discarded or abandoned or lost somehow and ends up in the marine and coastal environment.
Give me some examples.
Yes, so marine litter can be anything made of metal. It can be made of processed wood, so wood that's been machined by man, not driftwood, but things like your broom handle. It could be rubber. It could be lost car tires, glass, but it can also be made of plastic. So we know that plastic is usually the most frequent item of marine litter found, be that on beaches or in our oceans or in rivers. A lot of people, when they think of plastic litter, they're thinking of carrier bags, plastic bottles, things like that.
Apart from plastic bags, what do we mean when we talk about plastic in marine litter?
Plastic is a very difficult term to actually define. I think the main thing to know and to take away is that we use plastic in everything we do. The pillowcases, the toothbrush, the plastic water bottles, components of our laptops, our fridges. Everywhere you look, you're going to see plastic. So it is a big component in what we're finding in the marine litter and often what we are consuming every day.
How is plastic made? What is the primary ingredient that goes into plastic? Where does it all start? If it's making all these things, where does it start?
We know that we have plastic bottles, plastic toothbrushes, but how do they become a toothbrush? There are these things called nurdles, which are the pre-production pellets, often shipped across the world. So these pre-production pellets will be manufactured in one country and sent to another country to be melted down and turned into a plastic bottle or a toothbrush. And they're often called mermaid tears, which is a bit disturbing. So plastic get into the marine environment through a range of different sources, but what we want to particularly highlight here is the secondary microplastics result from the breakdown of larger plastics. So if you think about your plastic water bottle or your toothbrush, once it gets released into the environment, we've thrown it in the bin, it's ended up on the landfill, there's sun exposure, wind exposure, biological microbes. All of this will mean that there is breakdown of this item into smaller and smaller pieces. And that's why we're also finding nanoplastics in the environment.
Driver alarm's gone off. What's a nanoplastic?
We've got nano, micro, meso, and macro, and then megaplastics. And these all have a size range that they fit into that has been discussed with researchers across the globe and often debated at length to define what these size ranges are.
So what you're saying is there's different size ranges. Some of them are visible, some of them are invisible, and we'll leave it at that.
Perfect.
Okay. So when did we start finding this visible plastic? In fact, marine litter. Let's think about all of the different types of marine litter in this question. So when did we first detect that in the marine environment, Briony?
So marine litter is quite visible once it gets into the marine environment. I think everybody can think of a time that they were walking down a beach and they saw something washed up on a beach. But when did we first see it? That's quite a big question. Mm-hmm. We still know that the oceans are not as fully explored. We still don't know about every deep, dark corner of the ocean. An article on the BBC back in 2019, they reported that the continuous plankton recorder, which is a device that's automatically counting plankton in the ocean surface waters, caught a plastic bag off the coast of Ireland in 1965, and this is thought to be one of the first instances of noted marine plastic. Nowadays, we find it everywhere, all the time.
So how are we monitoring this across Europe?
In Europe here, we monitor marine litter in a couple of different ways. We look at the beaches, so the shorelines and the coastal environments, that macro litter that's getting washed up onto the beaches from the ocean. We also look at seafloor litter, so litter that's been deposited from the surface ocean waters down onto the seafloor, and that can be in our coastal areas or it could be in the offshore areas as well. And then we also look at macro litter inside some species of seabirds, and in the Mediterranean they also look at turtles.
So when you talk about macro litter, that's one of the larger sizes, larger than micro.
Yes, as Holly was previously describing, macro litter is the litter that's bigger than 2.5 centimetres, visible, easily picked up by a beachcomber, easily caught in a fishing net if we were looking at seafloor litter.
It might be good to jump in here with the fact that from a microplastic point of view, we've actually detected microplastics in the environment since the 70s. There was a paper that came out in the 70s about microplastics in the Sargassum Sea. It wasn't termed microplastics at that point, but it's not a new phenomenon. If we actually look back into the data and literature, we're likely to find it a lot further back than we originally thought.
Let's move away from the beach then. So you're talking about seafloor litter there. How can we detect seafloor litter if we can't see the bottom of the ocean like we can the beach?
Seafloor litter kind of has a close place to my heart because it's what I do a lot of. So we have a research vessel and we go out, and on our research vessel we are monitoring the seafloor litter that we collect as a bycatch of our fishing surveys. So we are not trawling for the litter itself, but it just happens that we catch it when we're also trawling for the fish that we want to look at. On the CFAS Endeavour, we've been monitoring the litter we've been catching in our trawls since 1992. It's one of the longest time series of data in the world for seafloor litter.
And that's why monitoring's so important, right, to get those long-term trends?
Yes. So when we first started recording the litter on our research vessel, there wasn't necessarily categories that we were recording them in. We were just recording presence, absence. As time has moved on and litter has become more prominent in the environment and also in the public eye, we now have set lists of categories that we use when we are collecting that litter to mark them down against, so that we can look at, are we seeing the same litter year after year? Is that changing? And also compare it to our counterparts in Europe, other countries. There are lots of different countries around the North Sea. We're all monitoring litter in the North Sea. It's good when we can compare data to each other.
So Briony's gone into a bit of detail how we can detect marine litter on the seafloor, which we can't see. How do we detect litter if we can't even see it with the naked eye, Holly?
That is a really exciting question, because I think a lot of researchers across the globe are looking at better ways to detect smaller and smaller plastics. We work on microplastics. We have a really great lab with state-of-the-art equipment that can look at these small plastics, look at the color, look at the shape, look at where they originally could have come from. So whether it was a plastic bottle or a thread that could have come from fishing net or clothing. We collect sea floor sediment, water and fish, and then we take that back to our labs.
Would you be able to describe getting those samples back to the lab? What happens once you've got those samples back to the lab, step by step?
Yes, I will take sediment as an example because it is probably the easiest thing and the thing that I have worked the most on. Sediment, we would get that back to the lab. We would usually dry it. It's a lot easier to quantify the amount of microplastics to dry weight of sediment. And this means that it's comparable across the globe because a lot of people are doing the same thing. So we would dry it in the oven. We would then put it in something like a SMI, sediment microplastic isolation unit. You would put either a very salty solution. You can make this with sea salt. You could use zinc chloride. So you would increase it pretty much like the Dead Sea. You know how people float on the Dead Sea? We're trying to float the microplastics in the water.
Okay.
So you would put this in a unit and float the microplastics.
So you've taken it out of the oven. You've put it in a beaker.
Yes, in a
beaker. Put it in
beaker.
a beaker, and then you've added water and salt to try and change the density so that the plastic comes to the top, and then you count how many there are to quantify the ratio of marine litter to sediment.
They would sit on the top, on that surface, and then you would filter that out, and you would use either low-cost techniques like a microscope or other more expensive techniques, and you would count size, look at the shape, and say where that plastic could have originally come from.
So are there any chemicals that you use to better spot those really invisible? I'm imagining a white piece of polyester thread that might be really hard to see within your sample. Do you use any chemicals to highlight marine litter?
So we do technique using Nile red. And what the Nile red does is it adheres to the plastic, and using a blue light, it can actually make the plastic shine. And this means that you're not spending hours trying to see whether it is fiber from a piece of clothing or a piece of hair or a polychaete leg or something like that. So it really has reduced our error and made it more reproducible across labs, across studies, things like that.
So for our listeners, a polychaete is a worm found in sediment. So Holly's described how we count plastic in our samples. Why do we need to count marine litter, Briony?
There's a couple of key reasons why we want to count litter, be it macro or micro. We really want to know the baseline. So what is there right now? What is the current state of the environment? From there, we can then look into the future. When we talk about monitoring, we're usually talking about long-term monitoring programs. So we don't necessarily want to just know what's there right now. We also want to know what's there in the future. And we want to be able to look back towards the past as well and see, well, what used to be there 10, 15 years ago. We try and do it on these long-term timescales so that we can see trends. We want to see, has the amount of litter increased? Has it decreased? Has it stayed the same? This is really important when we are trying to communicate our science to the general public or our science to the policymakers. So has the policy and legislation that they've put in place been effective? Have people changed their behaviours, and therefore has litter reduced because people are not putting as much litter into the environment or not using as many single-use plastic items?
So one example of that kind of behavioural change could be not taking a plastic bag to the shop, taking a longer lasting bag. As long as you actually take it with you, you just don't keep buying it every time.
Exactly. I think the introduction of the 5p bag tax is a great example of positive change, moving away from single-use plastic items, encouraging people to use reusable bags, and it's just become part of our general lifestyle now, to remember to have your canvas bag with you or your tote bag, always having a bag in your car so that if you pop to the shop, you haven't forgotten it. And it's just become part of life. And that's how some of these changes will end up changing our life in the future as well. It might seem like a change now, but it will just become part of normal day-to-day life in the future.
Why do we want to make sure we reduce our marine litter? Because marine litter is not very nice to look at. We want our environments to look more pristine, but what are impacts to the environment that we're trying to avoid?
I think a lot of people have seen the picture of the turtle with a plastic straw up its nose. That's quite a visual example of the harm that marine litter can cause to our marine environment and the flora and fauna that live within it. So that probably comes under entanglement. We talk about fishing nets that can entangle fish and other animals when they've been left behind in the environment. We know that animals will eat plastic. There have been cases of plankton eating microplastics, fish eating macroplastics. It's at all levels of the food chain. And then also there's the added impact of bioaccumulation. So when your plankton eats plastic and then your fish eats lots of plankton that's eaten the plastic, and then the shark eats lots of fish that have eaten the plastic, the shark ends up with even more plastic in its stomach because it's moved up the food chain. There's also issues around seafloor litter smothering things. So if you imagine a large plastic sheet or a tarpaulin that's landed on the seafloor and covered a 5 metre by 5 metre area, all of the things that were living underneath it now can't see the sunlight, they can't photosynthesize, they've been smothered by that plastic. Something that we're starting to look into is how non-native species are using marine litter to raft into UK waters. So we know that non-native species can travel around on ballast water, so they're brought in by vessels and ships on the water that's inside the ship tanks. Non-native species can also attach themselves to floating litter or to seafloor litter and use them as almost stepping stones to walk across the ocean surface or walk across the seafloor.
Floating across on a plastic bag, they might become resident in an area they might not have been able to travel to without that litter.
Exactly.
Okay, so I guess because the ocean is so vast that we're always learning about it, that is a real highlight to why monitoring is so important and why we're kind of focusing this episode on marine litter and how we can detect it so that we can keep a handle on how marine litter is affecting our environment and what we can do to reduce it.
Yeah. We know litter is there in the environment. We know what we need to do to reduce litter. A lot of people know they need to stop using single-use plastic or dispose of their waste correctly. But we also want to know what's happening to it within the environment. How is that changing over time?
Yeah.
Following on from what Briony has mentioned about why it's so important for monitoring and really the importance of the monitoring that's happening with this upcoming plastic treaty, globally people are coming together to discuss what can be done to solve the issue of global plastic pollution, whether it is mandatory or voluntary regulations or monitoring campaigns. I think the one thing is that we will not know if we're making a difference unless we can actually evidence that. And monitoring is the one way that we will evidence that. So we would be able to really target and pinpoint where that money can go and say, this is now the new problem. Because sometimes we're trying to get rid of one issue and we said, this is the biggest problem in marine litter. We look and we put an alternative, and actually then we can start seeing that alternative in the marine litter and data that we're getting. So we constantly have to feed back that information to governments so that they are using their money correctly and wisely to solve the problem.
Okay, so we've talked about detecting marine litter, how it can influence the marine environment. So you described that marine litter is coming into the marine environment, but how does that actually happen?
So the sources of marine litter is something that a lot of researchers across the globe are really focused on, and I think over the last 30 years we've got a much better handle on. There's been a lot of papers published on how they get into the environment, not just now but also in the future. For example, with the changing climate, how could a landfill site, for example, that you think is now covered and no longer operational, how sea level rise could impact that landfill site and therefore it become a source later down the line. So I won't go into all of the sources, but you can think about anything leaching into the environment. For example, landfill sites, dumping close to sites, often open dump sites, so not even regulated in landfills. Just littering on the beaches, a lot of the time where we're looking at local kiosks or places, recreational places where people are just throwing rubbish into bins, but these bins are overflowing and not being serviced. Poor waste management, leakage from sewage effluent. I mean, the list goes on. If you just look anywhere, you can just imagine wherever there are plastics, there is going to be leakage, whether it's a macroplastic or microplastics because of wear and tear.
So Holly just talked about some of the land-based sources of marine litter, but there's also sea-based sources. By that, we mean the fishing industry, but not solely the fishing industry. There's also recreational, leisure, shipping, transport. Anything that uses the ocean can be a sea-based source of marine litter. It could be a lost buoy, a piece of rope, something that you accidentally dropped overboard when you reached too far.
Pair of sunglasses. And we find these in the seafloor litter. We find, sunglasses, shoes, clothes, but we also find a lot of what we call ALDFG. And that's abandoned, lost, or otherwise discarded fishing gear. So it's what the fishermen were using to catch, and they will inevitably lose some of their gear.
isn't necessarily their fault. It happens. There was a storm, or when they went back to collect their crab pots, they just were gone because someone else trawled them up.
Or even recreational fishers when they have to lose a bit of line on a piece of rock.
Exactly.
Yeah.
I think even researchers with cable ties, gloves, things that you use,
Accidents happen, don't they?
Exactly. So we see a lot of that in the seafloor litter data that we find, and also in the litter that washes up on the beaches. A large proportion of that is ALDFG, or fishing-related or sea-based sources of litter.
ALDFG. Oh, that's quite good. It's quite a good rap there. ALDFG. What was it again?
Abandoned, lost, or otherwise discarded fishing gear. And I think it's often used in the media. It's often referred to as ghost gear or ghost fishing, if it's, a large net that's caught on a rock and is still catching fish. But we're also talking about tiny little pieces, net cuttings from where they've repaired a fishing net and a small 1-inch piece long of rope's gone overboard. That's still technically ALDFG.
It's not a snappy ALDFG.
I think we're also talking about sea-based sources. We can think about ALDFG from lakes and rivers and all of the fishing that's happening in lakes and rivers. And that isn't sea-based. This could also be from aquaculture. And this links to the fact that rivers can be a huge source to the marine environment and therefore becomes marine litter. So there is a lot of work that's being done to understand how litter moves through from terrestrial environments, through rivers, into the marine environment, and how that might change with droughts and floods. I think we've got to think about it in the sense that when we discard our toothbrush, when we put it in the bin, it gets into landfill, what's happening there? So a lot of the times we're not seeing these pathways, but there's very few barriers that are actually stopping what we use to get into the marine environment. And the only thing that's really going to stop is if we kind of build the circular economy and build a value for these products so that they're not becoming waste in the first place.
So what you're wanting people to do after listening to this is really think about what they use every day, where it's ending up. Because one word I really don't like is the word disposable, because it has to go somewhere, right?
Yeah.
So once you throw something away, it's then gone into the system you've described. So you mentioned circular economy. What is the ambition for a circular economy?
I think the overall ambition is really no waste.
Yeah.
It's as simple as that. I think sometimes we think cheaper is better, but we don't think about how long that is going to last in our environment, the impacts that's going to have on our water, on our food systems. And that all has an added cost. And that cost is not built into that cheap product. And actually we as consumers need to build that into every product we choose to buy and really drive the consumer market.
Yeah, it's a simple concept. It's probably quite hard to fulfill and to make happen. But as long as we're all starting to think about it and change our mindset, I think what's inspiring about what you're both talking about, what Briony mentioned about behaviours and how they impact in a positive way, then we just need to completely change our mindset from this, make something, have something, dispose of something, to make something, keep it, maintain it, reuse it, and it kind of never goes to waste, like you say. So that's quite inspiring to think about a circular economy, even though we might not know how to get there at this point, because we've had that kind of blueprint for human life all this time, but it actually changing our mindset into a full circle, which is the circle of life is something we're really familiar with. So why can't that be for marine litter as well? I really like that concept and kind of want to move on to an innovation aspect of the episode. So one thing we've talked about is counting marine litter. How are we going to do that moving on to the future?
So earlier when we were talking about how we are currently monitoring seafloor litter from trawls, that's probably not going to be the way we do it in the future. There's a lot of exploration at the moment into how can we monitor seafloor litter in the future in an environment that's so difficult to reach, so difficult to see. And there's been lots of advances in underwater camera technology over recent years. So a lot of people are starting to look at how can we see the seafloor litter in the imagery, be that videos, live videos, or photographs that are taken of the seafloor, and then how could we perhaps automate that detection? So rather than a person having to sit at a computer and look through thousands of images to see where was that one instance of litter, how could we maybe put that into AI machine learning or something like that could spot the litter and automatically detect the litter for us.
So AI, you're talking about artificial intelligence?
Yes.
And one thing I just wanted to clarify is, are you expecting that this will be on a vessel still and will have kind of a camera with a wire going underneath the water, or do you expect it to be kind of a buoy that is fixed in a position and kind of watches litter go by? How do you think it will look in the future?
I think that there are multiple different ways this could be done. So it could be done through a towed underwater camera, as you just described. It could be done through automated underwater vehicle that could sail around on its own, not needing to be manned or not needing to be attended to every day, and could be out for a week collecting data that could be sent back via satellite, or we could go and retrieve it and then get the data off it.
I know you spoke about earlier trawling for marine litter as you're recording marine litter in addition to your other work. So that's a way that we're doing it at the moment. So maybe if there's other work that is using these automated machines, such as oceanography, you could then combine these disciplines together to create a data set that covers a wide range.
Exactly. We know that lots of these vessels could be used to map out the seafloor in terms of the highs and lows of the seafloor, the topography, the geography. They could also have cameras attached to them that could be recording and looking for seafloor litter at the same time. It also means we could probably cover areas of the seafloor that we can't currently trawl. So at the moment we're restricted. We can't go to rocky environments. We can't go to some of the nearshore environments where trawling is banned, such as the marine protected areas. So these underwater cameras could actually look at some of the habitats that we can't go to with the current methodology and add to the data set we already have, as well as be the future.
Brilliant. So Briony's talked about under the water. Holly, is there anything above the water that we're doing in terms of technology for detecting marine litter?
I think Briony covered it really well. You would just substitute maybe drones for underwater cameras or things like that. I think there's a lot of excitement around utilizing drones. Drones are really accessible, and they're not just accessible to the UK, they're accessible across the world. And we can potentially utilize these to map out beach litter and use automated detection devices to categorize what we're finding. And again, it goes back to what Briony was saying, sites that aren't accessible, sites that are rocky. Currently, with traditional methods or manual methods, we're usually looking at sandy beaches. So could we look at other areas, mangroves, seagrasses, salt marshes? And I think the other thing is data, coastal erosion. All of that data is really valuable to policies, to scientists, and we can gather a lot more data than just counting marine litter.
We've talked a lot about so many things in this episode, so I just wanted to talk a little bit about our listeners. What decision pyramid that we can kind of go through when we're, okay, I can't get out of using this piece of plastic. What should I do? How can I make my impact smaller? What should I be thinking about?
I think the analogy you made earlier about the circle of life, it sounds so simple when you say it like that, but obviously it's not simple to implement, otherwise we'd all already be doing it. So I think it's really good to just kind of remind yourself or check yourself when you are making a decision about an item that you need to purchase. Does it need to be a single-use item? Would it be better to spend a little bit more money on something that you're going to use time and time again?
I think what we often hear is this reduce, reuse, recycle. But actually, I think talking about the circle of life, circular economy, I think we can go beyond. And actually, there's a lot of looking into this topic. And actually, there's repurpose, remanufacture. I mean, there's so many other repair. And I think it's like, it's not the reuse, reduce, recycle pyramid. I think it's actually exploded beyond that. Recovery, things like that. So it is a really exciting space. And I think there's so much innovation that can happen in this space. And that's where we really need to rely on entrepreneurs and innovators.
One of the things that we really like to do is communicate our science, not just to people of our own age, but also to children. And it's really great to speak to kids because they have such a different way of looking at things and getting their kind of perspective, but also explain to them at such a young age about what you could do to reduce your use of single-use plastic, bringing your water bottle, bringing a coffee cup with you, you know, simple things like that. And they just get it. And educating the next generation is just key to when we're talking about these kind of long-term issues.
there is a little bit of an attitude change starting to happen, and that's really exciting and inspiring. And that, you know, people have repair cafes where they take something that's broken they were going to throw away, and they, you know, somebody with a skill set repairs it for them. You've got people who every time they go to the beach they pick up at least 10 things. So I think that brings us to our fun fact, which is a feature of this podcast, and it's a topic of information or a nugget of information that our listener can take away with them. Conversation opener, maybe. So who would like to go first?
Briony would love to go first.
I can go first. The little nugget that I always love to pull out when I do particularly these school outreach events and things like that, help people think about how they can change that mindset when it comes to items they choose. So I always talk about, okay, so you've gone to the supermarket to pick your meal deal, and you've got your sandwich and you've got your snack, and now you need to pick your drink. And do you pick your drink in a plastic bottle, or do you pick your drink in an aluminium can? And when you think about, we know we're going to recycle it because we're good and we always dispose of our waste correctly, but a plastic bottle can only be recycled 1 to 10 times, where an aluminium can be recycled forever, for infinity. So it can be recycled over and over again, and it can be made into an aluminium can time and time again. So just that simple choice is just a really simple decision that you can make. Doesn't affect the price of your meal deal. Better decision.
Conscious decision.
A conscious decision.
I think an aluminium can of water just is a really nice switch that you can make if you really do need to get that meal deal. Holly, it's your turn.
I've spoken about my fun fact over and over again, and basically the circular economy is the future. I think we've got to figure out what our role is in the circular economy as consumers, as scientists, people who may be turning making their own clothes at home. Like, what is your role in the circular economy, and what are the opportunities for you and your family?
Wow. Yeah, just the fact that we can all change our mindsets. We can all do our little bit. We don't have to do it perfectly, but we can all make those switches. Yeah, that circle of life, I think, was a really nice way that we put it, that we're part of the natural circle of life. And as humans, sometimes we get disconnected from the natural world, but it's where we live, and it's where we want our next generation to live happily and healthily, and we need to do our bit to make sure that happens and we fit into that circle that you described. So I'd like to thank you both for this episode. I've really enjoyed going through how we can make a difference, some really inspiring aspects to this episode especially. So thank you.
Thank you.
Thank you.
Thank you for listening. This podcast was made by CEFAS, the Centre for Environment, Fisheries and Aquaculture Science. To keep up to date with us, follow us on social media using @CEFASGovUK. We hope you can join us again next time.